Want to learn how to create an eye-catching animation loop? You're in the right place. Before we dive in, just a quick note. This lesson is inspired by the Motion Master course by Oscar Pettersson. A big thank you to Oscar for giving me the permission to recreate these lessons in Blender. If you'd like to explore the same exercises and discover more creative ideas, be sure to check out his course. Today we're going to start creating the counter rotation loop. Let's start by creating a new file by pressing Ctrl-N and choosing General, or by going to the file, New, General, and I'll select all the objects in the viewport and delete them. Now I'll go over here to the corner. Once the plus icon appears, I'll click and drag to create a new panel. And I'll set it to Image Editor, then I'll scroll with the middle mouse and click Open, then choose the reference I'll be working on. I chose a Duracell battery reference, and you can choose any reference you prefer. So I'll go to File, Save As, and choose the location where I'll save the file, name it Counter Rotation, and add 001 to the name so I can use Save Incremental later, and Blender will automatically add a new number to each version. Now I'll switch to the front view by pressing 1 on the numpad, then press Shift-A to add an image reference and choose the same reference again. While the reference is selected, I'll go to its properties here and make adjustments like this. I'll try to center the reference manually by eye, then I'll move it back on the Y-axis. Now, to avoid selecting the reference, I'll go to the outliner, and from the filter, I'll choose the selection option. A selection icon will appear next to the reference. I'll click on it. This way, I won't be able to select it again. Now, I'll start modeling the battery. I'll press Shift-A and choose cylinder with these dimensions. I'll use X-ray mode to compare the model with the reference. It doesn't have to be exact. Nice. I don't need the reference anymore, so I'll rename it first, then hide it from the viewport and the render. Before continuing with the modeling, I'll organize the outliner, add collections, and name them. I can also assign different colors if I prefer. Cool. Now I'll select the cylinder and press Tab, then switch between vertex, edge, and face selection using 1, 2, and 3. I'll press 3 on the numpad, select the top face and the bottom face, then press I to inset with a value of 0.04 or 0.05. I'll get this result. Now I'll select this face and inset. I noticed this issue when doing the inset. It's hard to inset smoothly, so I'll cancel the inset, make sure I'm outside the selected face, then press I and inset with the desired value. Then I'll press E to extrude with this value. Now I'll create a gap between the metal part and the battery body in orange. Press 2 for edge selection, then press Alt to select this loop. I'll press Ctrl-B to bevel with a small amount, then press E to extrude inward. To see the extrusion, I'll go to the front view, enable X-ray mode, and press Shift to extrude with small values. I added a loop cut here like this, and I want to make this part slightly up to match the reference. So I press Shift plus Alt to select this loop, then press G and Z to move it up. I'll switch to the front to check the distance, then return to the perspective. I'll press Alt-click to select this loop, then press Ctrl-B to bevel it slightly with one segment in the middle. I'll add an edge loop with Ctrl-R here, then bevel it with Ctrl-B and remove the middle segment by scrolling with the mouse. The middle mouse scroll will increase or decrease the number of segments. I'll go to the modifiers and add bevel from the Generate section and adjust the amount, but you'll notice no changes. Then I'll scroll down to Geometry and uncheck Clamp Overlap. Now I'll adjust the amount to the appropriate value. I'll also add a subdivision surface by pressing Ctrl-2, or I can delete it and add it again from the Generate section and choose Subdivision. Choose whichever method suits you best. To make the model smoother, I'll right-click and choose Shade Auto Smooth. Now I'll temporarily disable the modifiers and continue modeling the bottom part of the battery. Press Tab, select this face, then press E to extrude with this value. Now I want to zoom in, but the zoom is too fast. To fix that, I'll go to Edit Preferences, then in the Navigation section I'll enable Depth, then I'll save the changes. Now the zoom will be slower and easier to control. Next, I'll press I to add a small inset, then press E again to extrude like this. I'll switch to front view and enable X-ray so I can see the extrusion depth. Hold Shift while moving to make fine adjustments just like this. Now I'll exit X-ray mode, go back to perspective view, and re-enable the modifiers. I might also increase the subdivision level. And now I can see the result. I'll make a small adjustment here by moving this part slightly upward. Using edge selection, I'll select this edge loop with Alt and Shift-click to select the second loop and bevel them using Ctrl-B, increasing the segments to 5. We don't necessarily have to stick to the reference exactly. The important thing is that we like the result. Now I'll make an adjustment to the bevel to make the gap smaller here. I want the gap to be even smaller, so I'll go back to edit mode, select this face, and press Ctrl+ on the numpad to expand the selection, or Ctrl- to reduce it. Now I'll scale it up while holding Shift, just like this. You can see the gap looks much better now. I'll do the same thing for the bottom part as well. I'll check the selection in wireframe mode. Pressing Ctrl+ will expand the selection, and Ctrl- will reduce it. I'll go to top view and switch back to solid mode. I notice that in top view it's showing the top part, but I want to see the bottom part, so I'll press Ctrl+7. Now I'll zoom in, press S, and scale it until it looks just right. Great, I've finished modeling the battery and the result looks excellent. I'll name it Battery. I have a small trick I like to use while working. When rotating around the object in the scene, I like to make the selected element the center of rotation. To do that, I'll go to Edit, Preferences, and under Navigation, I'll enable Orbit Around Selection. Now notice that the object is the center of rotation, and that's exactly what we wanted. Now I'll split the viewport into two parts like this. I'll dedicate this part to the camera, and I'll hide the gizmo and the overlays, and by pressing T, I'll hide the tool settings. I'll press Shift-A to add a camera, then I'll move it in the outliner and make sure it's in the camera's collection. Now I'll go to Render and set the render engine to cycles. Then I'll set the device to GPU. In the sampling section, I'll set the max samples in the viewport to 128 and the same for max samples in the render. Next, I'll go to the Output tab and set the resolution to 1080 by 1920 and the frame rate to 30 frames per second. For the frame range, I'll set it to start from frame 0 to frame 120. You'll notice the change in the timeline. By holding the scroll wheel, I can move left and right in the timeline, and by scrolling the mouse wheel, I can zoom in and out. Now I'll press Ctrl-Alt-Numpad 0 to jump into the camera view. Then I'll go to the camera settings from this icon and set the focal length to 300 millimeters to reduce distortion in the camera view. And I'll click on the lock icon here to unlock it so I can move the camera freely in the viewport. I'll zoom out the camera. If the camera is not focused on the object, all I have to do is select the object, and that way I'll be able to center the scene easily. Select the camera in the outliner, go to the object properties, and set the values as follows. Later I'll make adjustments to the camera as we progress. I'll exit the camera by pressing 0 on the numpad, then I'll go to the front by pressing 1 on the numpad. If the object isn't visible in the viewport, I'll select it from the outliner and press period on the numpad. This will frame the object. Now I don't need the camera, so I'll hide it from the outliner. Now I'll add the curve for the animation, but before that, I'll go to Edit, Preferences, and enable extra curves from the add-on section. Alright, I'll press Shift-A to add a curve, and you'll see that extra curves has been added to the menu. From the spiral section, I'll choose Archimedean. I'll set its dimensions as follows: 32 steps, radius 0.2, and height 1.4, roughly the height of the battery. We've got this curve. If we check it from the top view, we'll see it has a circular shape. Nice. I'll go back to the front view. I'll go with this curve and then exit edit mode. Now, I'll select the battery model. I'll go to the modifiers and add a curve modifier from the deform section. From the curve object, I'll use the eyedropper to select the spiral curve we created. Immediately, we'll notice that the deform axis is not correct, and the battery is not following the curve as we want. I'll change the axis to Z, and the direction will be fixed. However, there's an issue. The shape looks broken, or there aren't enough segments to smoothly follow the curve, even though we have added subdivision. The solution is as follows. I'll temporarily disable the curve and subdivision. I'll switch to the front view and press Tab to enter edit mode. Then I'll press Ctrl-R to add a loop cut. Using the scroll wheel, I can increase or decrease the number of loops, or I can just type the number I want, for example 24. Alternatively, After clicking once, I can adjust the number of loop cuts from the operator panel that appears in the corner. And that way, I've added segments to the model. Now I'll enable the subdivision and curve modifiers again, then exit edit mode by pressing tab. You'll notice the model is now smoothly following the shape of the curve. However, the object isn't aligned properly along the full length of the curve. So I'll select the object, press G, then double Z to move it upward along the Z axis. It also looks a bit small compared to the curve length, so I'll scale it up slightly. I'll enter edit mode, switch to face selection, and press A to select all the faces. Then I'll press S followed by Shift Z to scale the model while excluding the Z axis. Press S again to scale up the whole model like this. Press Shift Z to prevent it from scaling on the Z axis. The result looks great. I'll exit edit mode, and you'll notice the battery is now taller and fits better. Next, I'll press G, then double Z, and move it up to align it with the entire curve. Now, let's move to the animation step. I'll make sure I'm on the first frame. I'll switch to the front view and press N to hide this panel. Then I'll press Shift A to add an empty and scale it down to 0.2. In the outliner, I'll select the spiral curve, then press Shift and drag it into the empty to parent it. This way the curve is now parented to the empty. I'll rename the empty to master. Before I continue, just to make it easier for me to read and quickly find the objects I need, I'll simplify the outliner by hiding the content icons under each object. To do that, I'll open the filter menu and uncheck object contents. This is an optional step. Now, with the master empty selected, I'll insert a keyframe at frame 0 on the Z axis with a value of 0 degrees. Then at frame 120, I'll insert another keyframe with a value of 360 degrees. I'll play the animation. The result looks good. Now I just want to make the timeline area a bit larger. Select both keyframes by pressing A, then press T and choose Linear Interpolation. This ensures the animation loops smoothly without any stopping. Now I want to make the curve rotate around itself. Currently we can see that it's not the curve rotating, but the master empty that's doing the rotation. So I'll select the curve and go to the object properties. I could rotate it on the Z axis from here, but instead I'll press Shift A to add a new empty and name it SP01. Now I'll drag it into the master empty while holding Shift. Then I'll select the curve and parent it to the new empty. Now I'll rotate the empty SP01. At frame 0, I'll set the Z rotation to 0 degrees. At frame 120, I'll set it to 360 degrees. I'll select both keyframes and set their interpolation to linear. The animation now looks smoother and more fluid. Exactly what we were aiming for. If you look closely at the model, you might notice some artifacts. The fix is very simple. Select the object, go to the modifiers panel, and make sure the curve modifier is placed above the subdivision surface modifier in the stack. And you'll notice that the artifact is gone, and the object now appears much smoother. I'll switch to the camera view by pressing 0, and I'll make some adjustments to the camera settings like this. Now, I want to make a copy of this object. I'll go to frame 0 on the timeline. Select the SP01 empty in the outliner, and double-click on the icon next to it to select the objects inside. Then with the mouse cursor in the viewport, I'll press Shift D to duplicate it, and I'll rename it to SP02. And I'll also rename the curve. I'll create a second copy of the battery in the same location and name it Battery 2. I'll also rename the first battery to Battery 1. I'll select the second battery, and in the modifiers under the curve modifier, I'll choose Spiral 2. In the properties of the new Spiral 2, I'll set the Z value to 180. You'll notice that now we have two batteries rotating around each other. In the camera viewport, I can make the camera fill the view by going to the View, Menu, Cameras, and selecting Frame Camera Bounds. Great, we've finished the modeling and animation stage. Now we're going to set up the lighting and materials for the scene. I'll go to the editor type and choose Shader Editor. Then I'll switch from Object to World. The background will appear. Next, I'll go to Edit, Preferences. And from the Add-ons section, I'll enable the Node Wrangler and save the settings. Now, with the background selected, I'll press Ctrl-T. This will automatically add the texture coordinate and mapping nodes and environment texture nodes. Then I'll go to the top bar, scroll with the mouse, and switch from solid mode to rendered mode. You'll notice the background turns pink. That means there's no image or HDRI loaded yet. I'll click on Open and select an HDRI from the free pack I have. I'll go with this one. The lighting in the scene changes, as we can see, but I want the light to come from this side and the shadow to fall over here. So I'll rotate the HDRI. I found that 140 degrees looks good from earlier tests. Look how the lighting and shadows have improved now with more contrast. But I'll increase the strength value to 1.2 for even more contrast in the lighting and shadows. We can adjust the lighting later if needed, but for now I'll stick with the current lighting. Now let's switch from world to object. I'll enable the overlays and select one of the objects, then I'll go to the modifiers and temporarily disable them. Next, I'll press / to isolate it in solo mode. Then I'll switch to solid mode. Now I want to select the top part, which will be metallic, as well as the bottom metallic part, and I'll also select the label area in the middle. Before all of this, I'll press Ctrl-Alt-S to save a new version of the file. I'll zoom in on this part and select this face. Then I'll press 3 to switch to face selection. Next, I'll press Ctrl+ to expand the selection for the metallic area. And I'll press Alt-Z to view it in X-ray mode. With the faces selected, I'll go to the shader editor, click New to add a new material, name it Metal, and hit Assign. Then I'll press Ctrl-I to invert the selection. Now the unselected faces will be selected. I'll go back to the Material tab, and in the Slot section, I'll click the plus to add a new slot. Then I'll click New. Then I'll select the new material and name it Label, and press Assign. You'll see that the selection is fine, but I don't want the bottom part to be included in the label. So I'll select it separately and press Ctrl+ to add the parts I want and Ctrl- to remove the faces I don't want. Then I'll press Alt-Z to preview the selected part. After that, I'll choose the metal material and click Assign. While the metal is selected, if I press Select, only the metal parts will be selected. And if I choose the label material, you'll see that only the label part gets selected. Now I'm going to work on the label material. I'll switch to texture mode, set the metallic to 1 and the roughness to 0.35. I'm going to hide the overlays so I can see it without the wireframe. Then I'll move on to the metal material. I'll set the metallic to 1, adjust the base color to a slightly gray tone, and set the roughness to 0.3. Now I'll switch to render mode. Next I'll focus on the metallic part at the bottom. Some metals have a noticeable shine, so I'll go into the specular settings and set the anisotropic value to 1. You can leave it as it is if you don't want to change it, and that will give me this result. Now I'm going back to the label material to continue working on it. In our reference, the battery has both black and copper colors. To get those two colors, I'll press Shift-A and add a color ramp node. Then I'll connect it to the base color input. I'll switch to the front and check the color ramp result. We'll find that the result isn't what we want. So I'll select the color ramp, then press Ctrl-T to add this node to control it. I don't need the image texture, so I'll delete it. I'll connect the vector to the factor. Then I'll change the texture coordinate to generated instead of UV. However, I still haven't achieved the two colors like in the reference. The solution is to add a separate XYZ node. Then I'll adjust the color ramp. For the separate XYZ node, I'll set it to the Z axis. We're getting closer to the desired result, but the transition between the two colors is still gradual, and we want it to be sharp. The solution is simple. I'll go to the color ramp and change it from linear to constant. We'll notice that the color has shifted to black. So I'll move the black color back to its place in the color ramp. Then I'll drag the white color to the left until I get the result I want. I'll reduce the intensity of the black color, making it less pure black. For the white color, I'll click on the eyedropper and select this color from the reference. We'll get this result. I'll enable render mode. You might notice there's a shiny coating on the battery in reality. I can add this using the coat parameter. I'll increase the weight to simulate that reflective layer on top. Now I'll add the label to the model. To do that, I have to create a UV for the model, so I'll switch back to solid view and enable overlays. Then I'll select this circular loop. I'll switch to edge selection, press Alt and select the loop. I'll go to the bottom part and press Alt plus Shift to select this loop as well. The last selection we'll make will be from the back of the model. In our case, since the object wraps around itself evenly, the seam placement won't make a difference. So I'll hold Control and click this edge, which will select the edge loop between the two loops we selected earlier. The cut locations are now ready. Now I'll right-click and select Mark Seam. Now I'll switch to the UV editor. If I press A, we'll see the UV layout that Blender created for us. But I'll create the UV myself by selecting all the faces, then pressing U and choosing Unwrap Angle Based. Now we've got the UV that works for us, but there's a small issue. There's the black section, and we want to add the label to it. But on the UV layout, it's hard to tell exactly where to place the label inside Photoshop or Illustrator. So I'll enable overlays, then switch to face selection and select these faces. This area will hold the label. Then I'll go to the UV menu and choose Export UV Layout. I'll select a location to save the image and name it Battery UV. I'll set the size to 2048 by 2048. Both values must be the same, otherwise the UV will come out distorted. After that, I'll export it. Now I'll move to Illustrator to add the label. Now we're in Illustrator. I'll open the UV image we exported earlier. I'll notice that its size doesn't match the artboard. So I'll select the artboard tool and click on the image. This will create an artboard that matches the image size. Then I'll delete the original artboard and press Escape to exit the artboard tool. I'll add a new layer, and I'll rename the one with the image to UV. I'll double-click on the layer and set it as a template. Now I'll start by adding the reference image and designing the label. After finishing the design, I'll hide all the layers except for the label layer. I also need to make sure the label design is in white color so that it shows up properly in Blender. After finishing the label design, I'll export the image, give it a name, and make sure to save it in PNG format. I'll go back to Blender, click Open, and select the label image we designed. The image will now appear like this. Now let's add the image to the material so it shows up on the object. I'll switch back to the shader editor. I'll press Shift A and add an image texture node. Then I'll connect it to the base color input so I can see the label. After that, I'll deselect the faces. We don't need them selected anymore. I'll click Open and select the label image we designed. I'll see the image appearing on the object exactly where I want it. Then I'll select the texture node and press Ctrl-T to bring up the mapping controls in case I need to adjust its position. Also, I need to make sure that the texture coordinate node is connected to UV. Now, I want to see the result of the image along with the reference colors. First, I'll organize the nodes a bit. Then I'll press Shift A and add a mix color node. I'll connect the result to the base color, then connect the image color to input A, and the color ramp to input B, and with that we've achieved the desired result. I'd like to add some details like scratches and fingerprints to the material, as it will add realism to the object. I'll press Shift A and add an image texture node, then select the scratches image. I'll connect the color to the roughness input. Then I'll switch to Render View to preview the result more clearly. After that, I'll select the image, press Ctrl+T to add the mapping node and make sure the texture coordinate is set to UV. And to gain more control over the details, I'll add a color ramp node. I'll change the black color to a gray tone like this, and we'll start to see the details. You can press Ctrl-Shift and left-click to preview the node individually. For now, I'll make the gray a bit darker. Notice that the more I move the gray value to the right, the less visible the details become. You can adjust the scale in the mapping node, for instance, to 2. Notice the result. It's looking really good. Now I'll press Ctrl-Shift and left-click on the Principled BSDF to preview the material result. I'll notice that the reflections on the battery are too strong and the roughness is not showing properly. To fix this, I'll disable the coat. Alternatively, I can leave it as is and increase its roughness. This way, we'll get the result we're aiming for. Now I'll exit solo mode by pressing /. Then I'll return to the camera by pressing 0. After that, I'll re-enable all the modifiers and exit edit mode by pressing Tab. Oh, I forgot something. I need to set the image texture's color space to non-color because we're dealing with a black and white image. The reflections still don't look quite right, so I'll make sure the code is disabled. Then I'll disconnect the roughness by pressing Ctrl and right-clicking on the link. The result looks much better without it. Now I'll reconnect it, then I'll reduce the gray value even further. Great. The result looks much better now. Next, I'll move the gray slider to the right to get barely noticeable details. With a slight adjustment to the gray value, I've achieved the result I was aiming for. You may have noticed that the label isn't visible from the camera angle. It only appears on the back side of the model. The fix is simple. Go to the object properties and rotate the battery on the Z-axis like this. And with that, we now have a great looking battery material. Now I'll select the second battery and delete it. Then I'll select the first battery and make a duplicate using Shift-D. This way, we save time instead of recreating the material from scratch. I'll rename the new copy, then go to the Modifiers panel, and in the Curve modifier, I'll select Spiral Curve 2. And just like that, we've reached the final result. Now I'll make some adjustments to the camera. I'll hit play to preview the animation. It looks absolutely amazing. I want to add a background to the scene. I'll switch to the 3D viewport and Shift-A and choose a plane. Then I'll rotate it on the X-axis, move it back along the Y-axis, and scale it like this. With the plane selected, I'll go to the shader editor and add a material. I'll press New, choose a color, and set the roughness to 1. Then I'll rename the plane to BK. Now I'll join the two areas together. I'll press 0 to go into camera view, enable the render view, and hide the overlays and gizmos. And with that, we've reached the final stage of our project, which is rendering the scene. In the render properties, I'll set the render engine to cycles and the device to GPU. For the max samples, I'll leave it to 128. In the color management, I'll set the view transform to AGX, the look to base contrast, and I might increase the exposure. Then I'll go to the output properties. I'll make sure the resolution is set as needed with 30 frames per second. The frame range will start at frame 0 and end at frame 119. This way, the loop will look seamless without any visible cuts or pauses, as the first and last frames are repeated in the animation. I'll change the frame end back to 120 frames temporarily until I check that the first and last frames in the render are identical. To check, I'll press Shift plus left arrow or Shift plus right arrow. The start and end frames are identical, so I'll set the end frame to 119. In the output section, I'll select the location where I'll save the rendered images. I'll choose PNG as the file format, RGB for the color, and set the color depth to 16. Now I'll make sure I'm on the first frame, render the image, and check the result. Then I'll switch to the second slot, temporarily go to frame 120, and render the image for that frame as well. This is the result. Now I'll ensure that the first and last frames are identical in terms of lighting, shadows, and everything. I'll press J to switch between the two images. The result is great and matches perfectly. Now I'll set the last frame back to 119 and render the animation. And don't forget to save the file before rendering to avoid any sudden crashes or program closures. And once the render is finished, you join the image sequence into a video using After Effects or Blender or any other software you prefer. I've already explained how to combine images into a video using Blender. Just click the card at the top right to watch the tutorial. If you enjoyed the tutorial, visit our website for many free lessons across various 3D courses hosted on our platform.